Good morning. So I am Punityan. So today I will be taking up the numerical problems on the cantilever retaining wall. Okay. So before that, in the last class I have discussed what is a retaining wall. In that I have discussed regarding the cantilever retaining wall, counterfort retaining wall. So in that particularly, let me take up only the cantilever retaining wall. Okay. So what are all the different parts of the cantilever retaining wall, and when you will be going with a cantilever retaining wall, all those things I have discussed. So whenever the height is less than or equal to 6 meter, whenever the height of the soil that I want to retain is less than or equal to 6 meter, I will be designing the retaining wall as cantilever retaining wall. Okay. If it is more than 6 meter, I will be designing it as a counterfort retaining wall. Okay. And also I have discussed what are all the various parts of cantilever retaining wall. Okay. What are all the different parts? So the first one is the stem, the vertical structure. Next, the horizontal structure is the base slab. In base slab, it is the toe and the heel portion. Next, the various notations, that is the thickness of the base slab. Next, width of the base slab. Next, h, small h, that is the height of the stem. Capital H, that is the overall height of the retaining wall. So all those things I have discussed in the last class. Now I will be taking up the numerical problems of the cantilever retaining wall. Okay. So to explain the design of cantilever retaining wall, I have taken a question. So here is the question, just concentrate on it. Okay. Design a cantilever retaining wall to retain the leveled earth embankment 5 meter height. Okay. So what is the soil height that I want to retain? Okay. It is the 5 meter height above the ground level. Okay. Next, the unit weight of the earth is 16 kilonewton per meter cube. That unit weight is nothing but the density of the soil they have given. Okay. And the angle of repose is 30 degree they have given. What is that angle of repose? So it is the angle above which the soil slides. Okay. So next, they have given the SBC of the soil is 145 kilonewton per meter square. The coefficient of friction between the soil and concrete is 0.55. Okay. They have told us to use M20 grade concrete and Fe415 grade steel. Also design the shear key. So it's a new word. While explaining the different parts of the cantilever retaining wall, I have not explained what is the shear wall. Sorry, what is the shear key? Okay. So what is the shear key? I have not explained. So I will be explaining it while taking up the design. So they have also asked us, draw the following reinforcement details. Draw the following reinforcement details. The first one is the section of the retaining wall showing the details of the steel in stem, base slab and shear key. The second one that they are asking is longitudinal section for 2 meter showing the reinforcement of stem, base slab and shear key. The third one is the plan of the base slab through center showing the reinforcement. Okay. So this is the question. Okay. This is the question that I have taken. Okay. Now let me try to design by solving it. Okay. Let me go one by one. So I will be rubbing this. So now, before taking up the design of the cantilever retaining wall, let me give you the general procedure we follow to design any structure. Okay. So design means what? Okay. By considering some loading, we will be analyzing and designing. Finally, what we conclude? So what is the number of bars and what is the spacing of bars that I need to provide? So finally, I need to tell what is the number of bars and what is the spacing of bars, right? So finally design means, so it is the number of bars or spacing of bars that I need to provide. If I want to provide the number of bars or the spacing of bars, what I need? I need the area of steel. How much area of steel I need for that? So based on that, I will be providing the number of bars or spacing of bars. So if I want to provide the number of bars or spacing of bars, I want the area of steel. Area of steel, that is AST. How much steel you need to provide? So it depends on how much it bends. So how much it bends, based on that I will be providing the steel. So it means that I need to know the bending moment. I need to know the bending moment. MU. Okay. How much it bends? What is the load that you are applying on it? That much it bends. So it means that you need to calculate the load. It means that you need to calculate the load. Okay. So what is the load that is coming on the structure? The dead load. Okay. So dead load means I need to know the dimensions of the structure. I want to know the dimension of the structure. So always remember, in any design, okay, we always start with the dimension, okay, then load, then bending moment, then area of steel. Finally, we will be calculating the number of bars or spacing of bars. Here also will follow the same thing. So first I will be going with the dimension, which is the structure that we are designing. So it is the retaining wall. So first I will be going with the dimensions of the retaining wall. So now let me take up that. So before taking up, I always write the data given. I always write the data given. So what are all the data that they have given? So what are all the data that they have given? So the first one is, they have given the unit weight of the soil. Unit weight of soil, that is nothing but the density. Okay. So they have given it as 16 kilonewton per meter cube. They have given the SBC of the soil. They have given the SBC of the soil. So SBC, they have given 145 kilonewton per meter square. So what else they have given? They have given the angle of repose. Angle of repose. So they have given it as 30 degree. Yes or no? So next they have given the grade of concrete. So what is the grade of concrete that they have given? So use M20 grade concrete and use Fe415 grade steel. So Fe415 grade steel. Okay. So this I will also say it as Fu, FCK and Fu. So now let me concentrate the second part. Let me concentrate on the second part. Now I will be going with the dimensions of the retaining wall. Now I will be going with the dimensions of retaining wall. I will be sticking on to this procedure. Okay. So I will not deviate from that particular procedure. So it is the dimensions of retaining wall. So before that, let me write down a simple diagram of a retaining wall. Okay. So I will be writing the cantilever retaining wall. So what are all the different parts that we are in need of? Let me write it here. Okay. So now I want to know the height of the stem. So it is small h. I want to know the capital H. Okay. So that is the total height of the retaining wall. Next, I want to know what is the width of the base slab. Please remember, I want to know what is the width of the base slab. I want to know what is the thickness of the base slab. What is the thickness of the base slab? So two more things I will be adding here. So this I will be calling it as the width of the stem at the top, okay, width of the stem at the top, and this I will be calling it as the width of the stem at the bottom, width of the stem at the bottom. I think I have already told you people, so this is nothing but the toe portion and this is nothing but the heel portion. So keep this in your mind. Okay, so one by one we will go on calculating the values. Okay, so now the first thing is, so what will be the top width of the stem? So we'll assume, based on the experience we can assume it, as you people are new. So what we will do is, we'll assume the top width of the stem. We'll assume the top width of stem is equal to 150 mm. So it is approximately 6 inches. Okay, it is 150 mm. Sir, how you have taken it? Why it is only 150 mm? Nothing like that. You can go with 230 mm. Okay, so finally you will be doing the check, and if it is safe, we'll continue with this value. If not, we'll increase the thickness. Okay, so now, so top width of the stem, I got it. So bottom width, I will be keeping it pending. Okay, so let me calculate the other things. I think you people already know that this will be the ground level. This will be the ground level. They are telling that the soil that we want to retain above the ground level is 5 meter. The soil that we want to retain above the ground level is 5 meter. In the question itself, they have given. Yes or no? I think you people know that this particular distance is nothing but the depth of foundation. Yes or no? This you people know that this is the depth of foundation. So now what we will do here is, okay, I know what is the soil that I want to retain above the ground level, 5 meter. If I calculate the depth of foundation, don't you think that if I add this and this, it is nothing but the total height of the retaining wall? So that's why first let me calculate what is the depth of foundation of the retaining wall. So I think in your lower semester in geotechnical engineering, you people know what is the formula that is used to calculate the depth of foundation. So depth of foundation. Depth of foundation can be calculated using the formula SBC by the density of the soil into 1 minus sine pi divided by 1 plus sine pi, or 1 meter, whichever is minimum, or I can say or 1 meter minimum. 1 meter minimum. So what do you mean by that? So whenever you use this particular formula and you got 0.8 meter as the depth of foundation, so minimum you need to provide 1 meter. Okay, so now let me substitute and get the value of depth of foundation. So SBC they have only given, so it is 145 kilonewton per meter square divided by what is the density. So they have given the density or the unit weight of the soil as 16, okay, into 1 minus what is the value of sine pi? Pi value is 30 degree, so 1 plus sine pi. Okay, so and one more thing, it should be the square. So now if we solve this, so as if I use the calculator, it consumes time. So let me directly take the value. So it is 1.006 meter. 1.006 meter, or as I have already told you people, 1 meter minimum. So based on this I can say that take depth of foundation, depth of foundation, depth of foundation as 1 meter. Depth of foundation as 1 meter. So now let me continue here. I will be rubbing this. Okay. So now I got the depth of foundation. Observe here. I got the depth of foundation. I know what is the soil height that I want to retain. This is 5 meter. The depth of foundation is 1 meter. So I can easily calculate what is the total height of the retaining wall. Okay. So now total height of retaining wall. Total height of retaining wall is nothing but equal to, okay, that is the depth of the foundation 1 meter plus the soil that I want to retain above the ground level, that is 5 meter here. So now I got what is the total height. So it is 6 meter. So now I got this particular value. Okay. So now similarly I need to calculate the width of the base slab. I need to calculate the thickness of the base slab. So by practice, okay. So now I will be going with B dash, that is the width of the base slab. Width of base slab. I will be representing it with B dash. Okay. So which is given by 0.6 times H. See, whatever the assumption that I am taking, it's by practice, and in various textbooks they have taken this as the reference. It is not mandatory. Okay. So whatever the value that you are taking here, finally you will be doing the check for that. If the structure is safe, will continue, or else will increase. So there is no need to worry how you have taken it and all those things. Okay. So now 0.6 times H. So it is 0.6 times, so what is the total height? So it is 6 meter. So 0.6 into 6, it is 3.6 meter is the width of the base slab. So the width of the base slab is 3.6 meter. So B dash I got, total height I got. Okay. So now still I am in need of the thickness of the base slab. Okay. So I am in need of thickness of the base slab. So thickness of base slab. So thickness of base slab. So how to calculate that? So here also it is the H by 12 is the thickness of the base slab. H by 12 is the thickness of the base slab. Okay. So what is the height? It is 6 divided by 12. So it's 0.5 meter. So it's 0.5 meter. All these are assumptions. Okay. All these are assumptions. So now what are all the things that we have calculated? I have calculated the total height of the retaining wall. Okay. Next, I have assumed the top width of the step. Okay. Next, I have calculated the width of the base slab, and I have calculated the thickness of the base slab. Okay. So now whenever you know the thickness of the base slab and you know the total height of the retaining wall. Okay. So I want you people to tell me now. So total height H minus the thickness of the retaining wall. Don't you think that it gives me the distance from here to here, which is nothing but the height of the stem? So please remember. So I will be continuing here. So height of stem. So height of stem H is equal to, so total height H minus thickness of base slab. Thickness of base slab. Okay. So now what is the total height? So we already calculated it. It is 6 meter minus What is the thickness of base slab that we have calculated? So it is 0.5 meter. So 6 minus 0.5 meter, that is 5.5 meter is the height of the stem. 5.5 meter is the height of the stem. Okay. So now, so we have calculated B dash, we have calculated the thickness, we have calculated the depth of foundation, we have calculated the overall height, we have calculated the height of the stem. So what are all the other things that we are left out with? So toe matte heel. Okay. So toe and heel. So let me go with the toe portion. Let me go with the toe portion. Okay. So width of toe. So width of toe. Let me calculate the width of toe. So which is given by B dash by 3 or 1 meter. B dash by 3 or 1 meter minimum. So what is the value of B dash? So it is 3.6 by 3, that is 1.2 meter. So I got the width of toe. So what is the width of the toe that I got? So the width of the toe is 1.2 meter. Still, I want the heel projection and I also want the bottom width of the stem. So if I calculate the bottom width of the stem, I can easily calculate the heel portion. So now for that. So now I need to calculate the heel projection distance. I want to calculate the heel projection distance. So heel projection distance I want to calculate it. Okay. If I want to calculate the heel projection distance, I want to calculate the bottom stem thickness. So for that reason, what I will be doing is, first let me calculate the bottom stem thickness. Then I will be going with the heel projection. Bottom stem thickness. So it's the bottom stem thickness. So now what I will be doing here is, I will be concentrating only on the stem portion. I will be concentrating only on the stem portion. So here I will be showing the continuation mark because I am not in need of this particular base slab. I want only the stem portion because I want the bottom width of the stem. Okay, so for that reason I will be taking a section exactly at that particular junction where the stem and the base slab are meeting, and I will be calling that as XX. Okay, so now I think you people know that. So here you people will be having the backfill, that is the soil. Okay, so now, so backfill, don't you think that? So it's in a rectangular manner. So the soil pressure distribution. So soil pressure distribution diagram. So if you have studied, okay, so geotechnical engineering, you people know that the soil pressure distribution will be like this in a triangular pattern. Yes or no? Okay, so for triangular, okay, for triangular pattern, if I want to convert that into point load, where the concentration will come, so exactly at a distance. So what is this total distance? It is small h, that is the height of the stem. So if I consider the total height as h from 90 degrees side, so it will act at a distance of h by 3, and this I will be calling it as pH. So soil pressure in the horizontal direction. Okay, so now I think you people know this particular value, Ka into gamma into small h. Yes or no? So now I want you people to concentrate here. If I want to calculate the pressure, horizontal pressure over here, if I want to calculate the horizontal pressure over here, so this is nothing but, pH is nothing but half into base into height. I think you people know that. If I want to convert this triangular load into a point load, the formula is half into base into height. So first let me calculate that. Half into base into height. So I want to calculate the pH value. pH value is half into base into height. What is the height? So total height is h. Okay, so now if I want to calculate the pH value, so I know the density of the soil, I know the height of the stem, but I don't know Ka. What is that Ka? It is nothing but the coefficient of, active pressure. It is nothing but the coefficient of active pressure. Let me calculate that. So coefficient of active earth pressure. Coefficient of active earth pressure. K is given by 1 minus sine pi divided by 1 plus sine pi. Okay, so now 1 minus sine pi divided by 1 plus, we know the value for the pi. So let me substitute that particular value. So let me directly take up that value. So it is 0.33. It is 0.33. It is 0.33. So now I can easily calculate the horizontal soil pressure. Okay, pH I can easily calculate. Therefore, sir, why you are doing all these things? I will be explaining it. pH is equal to half into Ka is 0.33 into gamma, that is the density, into h is the height of the stem. It is 5.5 meter. There is one more time, h into h. So it will be h square. I will be taking the value directly. So the value of pH is 79.86 kilonewton. 79.86 kilonewton. So I got the pH value. Sir, you told that you are calculating the bottom stem thickness. Okay, then why you are calculating this pressure and all? Because you are retaining the soil here. Because you are retaining the soil, it means that the soil will be exerting pressure onto this particular stem. Okay, so where the stem is connected, so the connection is made between the base slab and the stem. So this portion is very critical. So I can't assume it as it is. Okay, I can't assume it as it is. So that's why I am doing the calculations like this. I have calculated what is the horizontal pressure that is coming on the stem. So now let me check. So what is the moment about this particular point? Okay, what is the moment about this particular point? What is the formula to calculate the moment? Force into perpendicular distance. So first let me calculate. So what is the moment about x-axis axis? What is the moment about x-axis axis? So it is nothing but force into perpendicular distance about x-axis axis. It is h by 3. So don't think that the x-axis axis is little bit upper and the axis that you have taken is over here. So they are almost on the same line. Okay, assume it like that. So you need to take it as h by 3. So it is force is pH into perpendicular distance is h by 3. So I know the value of pH, just now I have calculated. It is 79.86 kilonewton into h by 3. Okay, so the total height is 5.5 meter by 3 meter. So finally, so mxx value will be, so 146.41 kilonewton meter. 146.41 kilonewton meter. 146.41 kilonewton meter. Okay, so now 146.41 kilonewton meter. Let me continue with the problem. Okay, mxx, it's the value, working moment. Okay, mxx is the working moment. So as I want to check the thickness, I need to check it for the design moment. So I want the design moment here. I want the design moment here. So how to get the design moment? So mu is nothing but 1.5 times mxx, that is 146.41 kilonewton, which is nothing but equal to 219.62 kilonewton meter. It's 219.62 kilonewton meter. Okay. So now I think you people know one more. What is that? So when we were studying the RCC, I think you people remember this particular formula. So mu max, okay, is equal to 0.36 xu max by d into 1 minus 0.42 xu max by d into fck bd square into fck bd square, right? So using this formula, let me substitute the values and let me calculate that d value. So why we are doing all these things? So the heading, it was to calculate the bottom stem thickness. I am calculating the thickness. Thickness is nothing but the depth. Okay. So don't think the depth is a vertical portion. So for time being, I will be assuming this as the depth. I want to calculate this. Okay. So now, so mu max value, what is the value of mu max? Mu max value, will take it the mu value that we have calculated. So it is nothing but, what is the value that we have calculated? It is 219.62. It's 219.62. Okay. So everywhere it will be Newton mm. Let me convert this kilonewton meter into Newton mm. So multiplying it by 10 to the power of 6, 0.36 into. I think you people know that the xu max by d value, depends on the grade of steel. If it is Fe250, it is 0.53. If it is Fe415, it is 0.48. If it is Fe500, it is 0.46. As it is Fe415, it is 0.48 into 1 minus 0.42 into 0.48. FCK, grade of concrete, into breadth, okay, I will be leaving blank, into d square. What is the breadth that I need to take? I am concentrating on the stem. Stem, observe here. So if I try to write the 3D picture of this, write the 3D picture of this, okay, try to understand this. So it will continue like this. Okay, so this is the stem portion. It is almost like a slab. In slab, we always go with the spacing of bars. Okay, so always remember, whenever in slab, okay, always you need to consider breadth as 1000 mm per meter. So if we solve for d, so we get d is equal to 282.12 meter. 282.12 meter. That is the effective depth. So using an effective cover of 60 mm. Using an effective cover. Using an effective cover of 60 mm. So what is the overall depth? It's 282.12, okay, plus 60. It is 342.12, approximately, let me call it as 350 mm. Approximately, let me call it as 350 mm. Okay. So now, what is the heel projection that I need to take? Whenever you know the bottom stem thickness, whenever you know the toe, 1.2 meter, I can easily calculate heel. How? Because the total width, I know it, B dash. So if I want to calculate the heel projection, so heel projection, I know the total width, B dash. So B dash value is 3.6 meter. Next, I know the toe portion. So let me deduct it. Minus, I just calculated the bottom stem width, that is 0.35. So the remaining will be the heel projection. What will be the value of heel projection? That is 2.05 meter. So this is about the calculation of dimensions of the retaining wall. So the further procedure I will be continuing it in the next session. So thank you.